Okay, great. So I think the most important lesson is keep in mind this diagram. Whenever you write the code, we have a game object, right? And game object has multiple components. So also we can attach detached component, and the individual component has their own sort of parameter, which is value, and then behavior, which is function. So that we can access the variable. Sometimes you can fetch the right component to modify the parameter of the component. I think this is a really important concept and foundation for further examples. And interaction, yeah, I think interaction is really, really important, right? It makes sense because we are creating some interactive tool, right? First of all, when I hover over the, let's say, sphere and cube, I can keep print their name. Yeah, can you see this? And keep accumulate the number of console. Yeah. Okay, let's see how it works in the code level. Yeah, luckily we have inbuilt functions to detect the event. When hover over, when enter, basically when enter the geometry, and then we can print, basically we can execute this function. We can click the mouse left button on top of this mouse. Also, we can trigger this function. And then we also can track the mouse up events. Let's do this again. Clear, enter, oh, okay. Play, hover, click, 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 click. Yeah, while I'm click, they keep track my behavior. Mouse press, mouse up, right? The inside of code here, once the mouse up, we can not only just play console this information, but also we can increase the local scale. Yeah. By 0.1, 0.1, 0.1 along the x and y and z axis. Okay. So that we can increase the scale of the geometry that received my mouse in action. Great. Jump to other example. This is a little bit different approach to interact between mouse and the geometry. So while I'm moving my mouse cursor, right? Ooh, the cube follow my mouse direction just like that. And also we can see some debug here, some line, right? Yeah. The line from the starting from the camera position to the box. This is a lay because we rely on the lay cast methodology to pick the geometry. So you can see, you can go to that sort of reference that I link in this window. This is more about like a very high level description how raycast works. So we have a screen, right? So basically this is a screen space. This is screen space. While I'm moving my mouse cursor, we can track the x and y axis from this screen. Okay. So here, now we know, yeah, just like that. So we have an eye, and then this is the screen. So now we know the x and y of the screen position, right? This screen position is can convert from the viewport space to the all the way to the local, the geometry local space. We call this projection. So you don't need to worry about this kind of complex matrix calculation because the Unity already resolved this problem. But on the higher level, there's some like a position matrix calculation behind the scene. So this is the idea. Okay, camera has a main, and main has the screen point to ray functions, which is built-in function, right? So the input value is the mouse position, and then it gives us the lay. Yeah, the lay. With this lay, we have the physics test called the lay cast function, and just follow this syntax. Don't worry about it. Yeah, but the hit is the sort of the result. Yeah, And then it has a, yeah, I know it's very complicated, but just think about it. Hit is a component, and then using the dot notation, we can drill down the component of a component. Okay, so now the hit is the variable. Yeah, it has a collider. Yeah, once they collide it, something that it remember the game object. Yeah. Now we know, oh, we're very familiar with the game object, right? So game object has a name, also it has transform, right? Also we can get the some component, right? Like a mesh filter, for example, right? So this is what we learned previous to workshop, right? Examples, right? Oh, go away. So we can test, like inspect the name. The name is the ground. Then we are going to get the position information. And then using this position information, I'm going to update the geometry that we append. I mean, this cube here. Yeah. So now we know we are able to get the, at the end of the day, get the position of the how can I say, the ground that the lay intersect with the ground. And then I get the vector file, and then I update the vector file to the position of a cube. See this position, while I'm moving, they keep updating, right? It makes sense, right? Okay. And then let's go to the other example. The reached body. Yeah. Okay. So okay. So I'm gonna click the left button on top of this box. Keep click. Yeah. Which is like pushing the geometry. And then pull geometry on the right button. Pull, push, push. And keep push or pull the geometry. This is also event. Let's double click the C# component here. So when the mouse left button is the trigger, then we push the object further. And then mouse right button is the triggered, then we're gonna pull the box. So 0, 1, 2 is indicating the primary button, secondary mouse button, the middle button. There's more information if you guys want to know. Jump to the documentation. Yeah. So this is the, also we can receive the, not only click, but also we can track the which mouse button user can click. Yeah. Okay, let's jump to collision here. Okay, the box is oscillate, left-hand side, and then I can hover over the cube. And then while I'm hovering over the cube, they generated lots of sort of random sphere, right? And then also the color is different. When they collide each other, the event is happening, then they become red each other. Otherwise, the shine color is the normal color, meaning that they have no contact with the other spheres. Yeah, just like that. So collision is also sort of events, right? It makes sense, right? So here, all the this is the built-in functions to detect whether they collide each other or not. Yeah, this is the inbuilt function, and this is the key code. Yeah, so while hovering over the cube, we use the instantiation function so that we can duplicate the multiple game objects, right? That's it. And then individual, the sphere has this line of codes. So they themselves individually, they execute this code again. And so when they collide each other, then they become like a red color. Otherwise, they maintain the shine color here. Yeah. And also, the interesting thing is that we can turn on the gizmo, yeah, so that they draw all the line if they based on the history of the collision. If they collide each other before, then they draw the line, which is interesting because the data visualization is one aspect of it is just visualizing the data literally, and the other way around is we can actually filter or draw create the other sort of data to generating and processing the other data to visualizing, because if it is process the data can have a more insight, just like that. So the line looks like very complicated, but think about it, the line is basically visualizing the relationship between the spheres based on whether they collide or not. Yeah, this is the one way of doing this. And the other one is keyword event. Okay, let's jump too quickly. We have a lack of time. Yay. So actually, now I'm pressing my keyboard, all keyboard, like left, right, up. Yeah, I'm keep pushing this box. Keyboard is also events. Yeah, I'm keep pushing one of the boxes here. It's too slow. I can help. Go away. Yeah, we can make him far off. Okay. Yeah, these are pretty much about it, because I have something more complicated later. So we have this inbuilt function to detect which key user can press or not. So if the user press the left arrow, then we can do this. Or if they click the right arrow, then do this. Yeah, it's nothing complicated. It's just very simple. But I have the other little complex example, which not only contains the first example, but also it has other laycast and some collision history things. So if you guys later, you can take a look at the code, because they're basically very similar to each other that I already showed to you. So you can see the result. Yeah, when they collide, they become like red, right? And then there's no collision. The sign color is happening. Okay, I can, oops. I can keep navigate this box, can collide, hit, okay. So now they actually display, track my behavior in the console or my actions. However, if you click the one of the sphere, this sphere is number 5, and then they display all the history of a collision. Yeah, I can click it. The number 7, this cube is 0, and then collide with number 1, 3, 4, 4. But however, collide with the number 3 is 4 times. We basically track all the behavior and then visualizing the data later. So this is also interesting interactive visualization, because just visualization is just showing some numeric data to the visual language, but also in active visualization, we have the other dimension to track the user behavior, how interact with the data. This is also become like a useful data to process our original data anyhow. Yeah, so any question for the interaction? Okay. The UI, yeah, UI is nothing special. I just add some button component here, and then once you click this button, you can do something. Yeah, I can keep pressing button 1, and then this print the name of the button here, right? So double click the C# component here. Nothing special. We have a button which is already exists there, and we found function with the name. Then we can found the game object. However, we are not interested in game object itself. We are interested in the button component that belongs to the game object that we are going to select. Okay, so using this kind of fashion, we can only select the component, and then using add event, we can add this function to that button. Okay, so here, if you click the canvas, canvas has the two buttons. This is game object, right? And then it has a button here. And then we can append the event to the game object. So let me play again. Because these buttons already exist on top of the canvas. Canvas is okay. Canvas is the sort of a space. It's not a three-dimensional space. It's two-dimensional space. Only belongs to camera because I attach the camera to that the renderer. So in this case, let me double-click this canvas. Yeah, this canvas is always belongs to camera regardless of the position or location of the camera, and also we have two. Let's say mouse button here, which is also game object, right? And also it has the button things. That's why we use this get component button. Yeah, that's it. The UI event. Let me double click it and play. So here's a small sphere oscillating along the x-axis. If you click the shoot button, we can populate the sphere, right? And also we can print the number of the spheres that we shoot, right? If you click the reset button, everything is reset. Yeah, remove all the geometry. Even we reset the number of the sphere, which displaying on our screen as a UI. Shoot the sort of sphere and the reset. It's nothing special. It's how bind between button and the actual functions. Here, so in the start execution, I grabbed all the button and then bind these two function. So when you shoot the click the shoot button, and we're gonna execute this button. When you click the remove or reset button, we're gonna I'm sorry. Okay, this is the generating. This is the remove button. When you click the shoot button, so in this case here, like a shoot button, yeah, and then we execute this line of codes. Duplicate the sphere, and then randomize scale, and then reposition, and then we apply the randomized scale for the sphere, and then attach the rigid body because we want to apply physics simulation, right? And then we play with the mesh a little bit, and then we need to shoot the rigid body to the air, right? So that I apply the some air force, just like that. We can play with this the strength of the z vector, like an up vector. Then you can sort of adjust the speed and then the strength of the shoot. Yeah, that's it. Play with this number, then you can have a better sense because I'm keep accumulate this the knowledge on top of each other. I'm intentionally like use the previous example for this example, for example. Okay, yeah, we can also use the image as a UI. There are multiple diverse ways, but I just focused on the how we import image and display image as a sprite in this example. Okay, double click the C# code here. Pretty simple, right? just go line by line. Okay, we wanted to grab the canvas because canvas is the like a foundation of the UI because it belongs to the camera, right? And also we wanted to create the game object. As I mentioned, every object in the Unity is a game object, right? So we have a game object, and then we can reset the position, right? This is the interesting line of code. We wanted to make a parent-children relationship. Just think about it, this example. We have a canvas, right? A previous example here. Where are canvas? Okay, canvas. Oh, come on. Okay, we have a canvas, right? Canvas has these two game objects, which is button. Yeah, meaning that they have a parent-children relationship. Meaning that if I change the position of a canvas or scale of a canvas, the children are gonna be follow automatically. They like become one body. Yeah. So I make some children-parent relationship here, and then make some rectangle position because I wanted to reposition the game object inside of the canvas. So in this case, we use the let transform. I think this is important thing. Yeah. We have image PNG in that folder, and then we'll read this image as a byte. This is a C# built-in function. And then in order to convert this byte to the image, I mean, let's say texture in the Unity context, we need to create the text2D class, which is component. And also we have the special function which load image. Then we are successfully done the convert image to the texture 2D. Okay. And then this is also important thing to convert texture to the sprite. The reason why we need to make a sprite is because the image component needs a sprite. Yeah, so simply we can connect sprite. So once you play, I don't like the floating menu. Okay, I mean from the Zoom. Click the play button. Oh no, it's not. Where are you? Click the button, then something happening behind the scene, which is imported PNG as a byte, and we're gonna build texture 2D out of a byte, which is from the image, right? And once we create the texture 2D, then we can convert texture 2D to the sprite, so that we are able to attach this sprite image. Yeah. Okay. This is just fashion in the Unity, so sometimes we need to just follow the how the individual data works inside of the Unity world.